To get an expression for energy eigenvalue of the hydrogen atom, we have to start our journey from our recursion formula. This is the recursion formula. To get an acceptable solution, the power series must break off after a finite number of terms. Therefore, the numerator of equation 49 should equal 0. To get an acceptable solution, k plus L plus 1 minus lambda should equal 0. Therefore, lambda equal to k plus L plus 1, which is equal to n. So this is 50 here. N is principal quantum number. The value of n equal to 1, 2, 3 and so on. K is our radial quantum number. The value of k equal to 0, 1, 2 and so on. Now we have to derive an expression for energy. Already we have substituted the value of 2 mu by h cross square into E equal to minus alpha square. 2 mu E by h cross square is alpha square, then mu z E square divided by h cross square alpha equal to lambda. These are all the substitutions we are given. Now lambda equal to n. Here lambda equal to n. Then lambda square equal to n square equal to mu square z square e power 4 divided by h cross power 4 alpha square. Then alpha square is minus 2 mu e by h cross square. Substitute the value of alpha square here. N square is equal to mu square z square e power 4 divided by h cross power 4 into minus h cross square divided by 2 mu into e. Just we have substituted the value of alpha square. This is n square equal to minus mu square, just mu square mu cancelled out, so minus mu z square e power 4 divided by 2 h cross square e. From this we may give the value of e. From this relation, E equal to minus mu z square e power 4 divided by 2 h cross square n square. This is the value of energy eigenvalue. Now if you consider the equation n equal to k plus L plus 1, if n is greater than 1, the system is said to be in the state of degeneracy. If n is greater than 1, the system is said to be in the state of degeneracy. The meaning of degeneracy is known to you. Multiple eigenfunctions corresponding to only one energy level is called degeneracy. Psi1, Psi2, Psi3 and so on are the eigenfunctions. If all the eigenfunctions are corresponding to a single energy level E, then the system is said to be in the state of degeneracy. If the value of n is greater than 1, the system is said to be in the state of degeneracy. We have to prove the same with the help of an energy level diagram. To realize more about this, consider n equal to 2. The principal quantum number n equal to 2. The orbital quantum number values are 0, 1. For the given value of n, L can have 0 to n minus 1 values. So the possible values are 0 and 1. Suppose the value of n is equal to 2. If L is equal to 0, the value of m is equal to 0. Suppose the value of L equal to 1, the possible values of m is minus L to plus L inclusive of 0. Therefore, the values of m are minus 1, 0, 1. These are all the three values. So that we can have four combinations. n equal to 2, n equal to 0, m equal to 0. This is one combination. n equal to 2, then next possibility, l equal to 1, then m equal to minus 1. This is the second combination. n equal to 2, l equal to 1, m equal to 0. Third combination, n equal to 2, l equal to 1, m is equal to plus 1. This is fourth combination. These are all four possible states, but all the states are corresponding to only one energy level. For the given value of n, for the given value of n, the degeneracy is n square. Here the value of n is equal to 2, the degeneracy is fourfold. These four eigenstates are corresponding to single energy level E. Then only we can say the system is said to be in the state of degeneracy. With the help of an energy level diagram, we can do this. See this energy level diagram. Here n is equal to 1 is representing the ground state. If n is equal to 1, the value of L is equal to 0. In the case of n equal to 2 state, the possible values of L are 0, 1. Because for the given value of n, L can have 0 to n minus 1 values. Here n is equal to 2. Therefore, the possible values of L are 0 and 1. If L is equal to 0, the magnetic quantum number m is also 0. Suppose the value of L is equal to 1, the possible values of m are minus 1, 0, plus 1. So here L equal to 0, m equal to 0, then L equal to 1. The possible values of m are minus 1, 0, plus 1. Here n is equal to 2. These four eigenfunctions corresponding to only one energy level. This is called degeneracy. Suppose for the given value of n, the degeneracy is n square. Here n is equal to 2. So the degeneracy is fourfold. You can get four eigenfunctions. All the four eigenfunctions are having the same energy level. See, the eigenstate is represented by the formula psi n L m. This is the ground state psi 1 0 0. The principal quantum number n is equal to 1. L equal to 0, M equal to 0. The state is psi 2 0 0. See here, the principal quantum number n equal to 2. L value is 0, M value is 0. This is psi 2 1 minus 1 state. This is psi 2 1 0 state. This is psi 2 1 plus 1 state. See, all the four eigenfunctions are having the same energy level. This is called the degeneracy. If n is equal to 3, the degeneracy is 9-fold. Just we can have 9 eigenfunctions corresponding to the same energy level. That's all about the energy eigenvalue of hydrogen atom.